Well, good morning, good afternoon, good evening, maybe even good night if you're a night owl, to everyone, wherever you may be across the world. Thanks so much for joining us here live today for Serverless Office Hours. We are streaming on the AWS Twitch channel, on YouTube Serverless Land, and also via LinkedIn Live. We've got a super interesting stream for you today, and we have three experts who are going to be joining us and talking about some really cool stuff. First of all, Aditya, who's a product manager for Lambda. Aditya, tell us just quickly about your journey to AWS and what you do in Lambda.
Sure. Julian, you already covered my name. My name is Aditya. People find that hard to pronounce, so Adi, Aditya, whatever you want to say. Right? It's coming up on 2 years that I've been a PM at AWS Lambda, and time really just does fly. And it's a little scary.
So is that more or less than dog years? Is that sort of, more? Never could work that out.
That stuff always confuses me. Let's just call it dog years. But yeah, so I look after bringing resource-intensive workloads to Lambda and figuring out what customers need and trying to sort of tinker in the background to make things work beautifully and smoothly so people can run interesting stuff. And yeah, I'm so excited about this conversation. Like, I think it's such an interesting topic, and like we're going to dive into like a super cool use case. So I'm just excited to like get Gil and Eoin talking about it.
Excellent. Well, yeah, if you haven't spotted, we've got two other experts, Eoin Shanaghy and Guilherme Dalla from fourTheorem. So these aren't AWS people. These are people who are building stuff in the real world. Eoin, yeah, tell us about fourTheorem, and welcome.
Hi, Julian. Thanks very much. It's great to be here. Yeah, so fourTheorem is, I suppose, a boutique AWS consulting partner, an advanced consulting partner based in Ireland and also working out of the UK as well. So we do a lot of the kind of work we do is mainly kind of migration work. So application modernization, we're big into all things serverless and ECS as well. So we end up doing a lot of kind of map migration projects to AWS for customers who are on premises or kind of halfway there. So that's the kind of stuff that myself and Gil are getting our teeth into on a day-to-day basis.
Excellent. Now, you're a software engineer, so you sort of hands on keyboard making this all happen?
Yes, and I've been doing that for quite a while. So my background is like I used to be like full stack developer, and would say like from 4 years to now, I've been focusing a lot on serverless. So since I joined fourTheorem, helping like these customers migrate into the cloud and being serverless first, having this approach.
Excellent. Well, we're going to hear more about fourTheorem and yourselves as well. But actually, Eoin is also a podcast host himself with a really good YouTube channel. Lots and lots of good content. So, yeah, I'll post a link to that shortly once we get going. But yeah, plenty of information from Eoin on the YouTubes as well. So just looking back over the last week of serverless, if I can click on the right place, last week's stream was heading over sort of into the containers world, which is really interesting. And this was a Copilot for serverless containers, a really useful CLI tools to be able to do the sort of full life cycle of serverless containers. And that means sort of ECS on Fargate. And Effie did a really great job with a really good demo. And I was super impressed and learned a lot about it as well. So that's along with all other serverless land videos on our YouTube channel going back, I think, a few years now. It's nearly 2 years now. We've been doing it, so plenty of streams, lots of information. In terms of what's new in AWS Serverless, I'm actually going to go down to the third one first. Step Functions has come out with versions and aliases. So we know how Lambda does versions and aliases. Well, Step Functions now has that as well. Super useful. Get lots of questions about how you can test Step Functions, how you can roll Step Functions out in the wild and update them safely. Well, this is a really good release to help you with that. The SAM team have got two things, a remote invoke for Lambda. So that's just, even though you can use the AWS CLI from the command line to remote invoke your Lambda function. And now it's just bundled into the SAM CLI as well. Just another tool you don't need to learn, and you can use SAM for all of your remote invoke and your Lambda functions. And it's got some nice ways that you can also import the event object you need, which is super useful. And also SAM now has AppSync abstractions. So lots of people have been asking about that. When you're building serverless applications, SAM makes it easier with those cool abstractions. And yeah, now you can also use AppSync as well at the same time. And since we are talking Lambda today, if you are doing data processing, Lambda also supports starting from a particular timestamp for Kafka event sources. So yeah, lots going on in the Kafka and Lambda world. It's one of my sort of favorite use cases for Lambda is being able to do data processing. And remember, Kafka can be from your managed streaming for Kafka, which is an AWS service. And it can also be Kafka that even runs on-prem and Kafka, in fact, anywhere. So really useful. And now you can actually set a specific timestamp to when to start your data processing from, and you can use that for, I suppose, like DR scenarios or something we need to pick up from a specific time. A whole bunch of compute blog posts that are sort of relating to those, going into some deep dive details with often a lot of code behind that, but also top another one of my data processing-ish, I suppose, things, Amazon SQS. Well, looking at the AWS well-architected framework and implementing that for SQS. So yeah, it's a 3-part blog post, which Chetan and Hardik, one of our internal gurus on SQS, have come out. So yeah, that would be super useful if SQS is of interest for you. Now, looking a bit further into the future, on October the 26th in Nashville, Tennessee, there's actually an EDA day, Event-Driven Applications Day, which is brought to you by AWS and GoTo. So the GoTo are organizing the conference, and myself and a number of people are hopefully going to be there, and it's going to be a really great day. We did EDA Day in London last year, which was absolutely brilliant. Had, so many people over there, and just really getting to the crux of what how you can build event-driven applications and all the power that brings. And so yeah, mark that in your diary, 26th of October 2023, EDA Day in Nashville. So before we get on to the topic today, which is high performance financial modeling, I think that somehow dropped off the slide because my font was too big. But we're actually talking about HPC in the cloud. But just remember, your questions or comments are valued. We are live on office hours, so whichever stream you are joining us from, please, send us your questions and comments, and we will see how we can address them. So yeah, remember, we are live. So that's enough waffle from me in the beginning. We're going to sort of head over and talk more about high performance stuff. And yeah, Aditya, you want to start us off?
Sure. I have some more waffling to do, so I don't want.
At least it's not mine anymore.
False promises other people. Yeah. Well, yeah. I mean, yeah, I'm so excited to talk about this topic specifically. And I've worked with Eoin and Gil on this workload in the past as well. And so what I wanted to do, they have all the interesting content, all the cool sort of stuff to show. But before they do, I just wanted to talk about this workload pattern and what we've seen from a Lambda standpoint and what makes us so excited about it and why. I'll have to take off my Lambda hat at certain points and put my serverless hat on and talk about the broader solution, but why we feel this sort of there's so much unrealized potential with Lambda and Fargate and serverless things like step functions being used to do really intensive stuff in the cloud. Right? So I guess let me start off by saying, you might have seen this sort of slide and this wording in a couple of other places, but when we talk to customers, a lot of the times people think about Lambda being used for sort of small, simple and small scale workloads. So like, hey, the common example you'll see in workshops is like, hey, image thumbnail resizing, right? Or like, hey, you want to do some payload manipulation or SD data movement. And Lambda is great for those things. And we're very, very happy that Lambda is great for those things and enables a bunch of application patterns. But we've seen customers do some really, really cool, interesting things. And a lot of customers do it, right, over the last few years. So, we're going to talk a lot about HPC and loosely coupled HPC today and how customers are able to take advantage of Lambda's scale out capabilities to process and analyze and do a bunch of cool things with large amounts of data. Right? The same thing with sort of petabyte scale data query engines. So customers, it's just chewing through, sometimes it blows my mind the amount of data that customers are able to chew through just Lambda at scale, right? Just going through, pulling stuff down from S3 and returning results back to customers in seconds, right? And similar with all the high throughput ETL pipelines and all the detection workflows, right? There are all these workloads that are, I'll talk a little bit more about common themes, but they sort of rely on Lambda's ability to just handle large amounts of traffic to deliver insights to their customers in really accelerated time periods, right? I'll talk about a few examples, and obviously, RennaisanceRe and fourTheorem are front and center because we're going to go into detail there. But just to give you a few examples of what customers have done, and all of these are case studies that you can find. Just look up AWS other case studies, you can get more into detail with all of these, right? So for example, I'll pick on CS Disco, the cool logo on the top left, right? They do some really, really interesting, they were able to sort of modernize the way legal document ingestion is done during legal discovery using Lambda to sort of do rapid NLP, right? So a bunch of legal documents are ingested. You spin up a bunch of Lambdas. They sort of identify patterns and content, right, in the documents themselves, and allow legal experts to dive into that data faster. Honeycomb presented in the NYC Summit in 2022. So some of you may have seen their workload pattern, but they use Lambda at scale to power their query engine that powers their observability platform. So customers can write a query. In the background, there's a bunch of Lambdas that are spun up that go scan through S3, pull data down, do a bunch of analysis on them, and return results to customers in seconds, right? And it's incredible. Right?
Yeah, I love that sort of thinking about it, because a lot of people thinking all this HPC stuff, oh, that's really slow, big workloads, yes, we may reduce the processing time from 100 hours down to 10 hours, but like really that's not really sort of helpful for me when I need more immediate results. So yeah, that Honeycomb use case is great, because it's literally people on a website wanting to do observability, type in the queries, a whole fleet of Lambda functions go off, do their crunching, aggregate it, and you get it back in seconds.
Yeah,
so, love it.
Exactly. And I think obviously the word high performance computing has a lot of weight associated with it, from what people think about as HPC. But just if you take the sort of crux of that word, just compute, doing things really, really fast with large amounts of data, large amounts of compute, then all of these patterns sort of meet that need, right? And there's a couple more examples, but again, just sort of skipping to what's common across these workloads and what sort of makes these high performance workloads so great for Lambda, right? A lot of them have time sensitive results, and it's usually, hey, I need to make this decision in 20 seconds to respond to a deal, or I'm iterating on something and I just sort of need it to go fast because it's coupled to my productivity. So if I'm a designer and I need some simulation to be run for me to come back and tweak a few things, it's kind of painful for it to take 30 minutes. I mean, it's a good coffee break for people. It can go up and down, but too many coffee breaks is probably a problem. So accelerating that ability to get results to use sort of business decisions or technical decisions. Now, these things, you can sort of handle that. You can spin up a bunch of compute to handle that any other way. But what makes Lambda really special is when you have sort of unpredictable spiky demand coupled with that. So for example, analysts are running queries at random points during the day. You can't really predict demand, and Lambda's ability, again, I'm going to say scale up and scale in a lot, but the ability to sort of take in that load, spin up a bunch of compute, and spin it all back down when the processing is done makes it really special as well. So people are able to derive its sets, right? Yeah.
I'm just going to jump in, Aditya, because Frankel81, thanks for joining us via Twitch. So so the speed gets achieved via horizontal scale, and so if you're wondering, what magic is going behind the scenes, this is actually the kind of thing that's happening. And I'm just thinking in my head at the moment, Lambda in our big regions can burst to 3,000 concurrent invocations. So 3,000 Lambda functions can happen at the same time, and you don't have to phone us up or do anything. That's just going to happen. But because Lambda can run 10 gigs worth of memory, that is 30,000 gigs of memory. So 30 terabytes of memory available in milliseconds. And also because Lambda can scale up to 6 virtual CPUs, that's 18,000 CPU calls that you can have like that without you having to do anything. So if you are trying to understand the horizontal scale, that horizontal scale can be super powerful with the concurrent requests.
Yeah, and thank you for doing the math for me, Julian. Math is not my strong suit, so
that would have been mean if I just said, "So did you tell me how many?"
But yeah, those numbers exactly, and that's super cool, right? The last couple things, I think they're sort of inherent with these workloads. Now, for you to be able to take advantage of the horizontal scale, you need to be able to parallelize individual executions so things can run at scale in parallel. And again, high performance computing typically means calculations and simulations are going to be computationally expensive in some sense, right? And my last slide, I promise, and then over to Eoin and Gil. And just to reiterate why Lambda is such a great option for these workloads. And I talk a lot about Lambda, but some of these benefits, especially I'm going to talk about the common workload means these solutions really make sense when you consider not just Lambda, but you start pulling together other components from our serverless portfolio as well, right? For example, you want to optimize for cost, or you want to optimize for sort of certain types of workloads that can't fit into Lambda's constraints. Maybe you need more memory than what we support. That's why we have a portfolio, right? And that's why it makes it you're going to see, as Eoin and Gil talk, how you can stitch together various compute options to build a really, really interesting platform to serve your needs, right? But if I put back I have a Lambda hoodie on, so I'm going to talk a little bit more about Lambda, but it's really sort of compute speed and scale, right? So many event source integrations, so it makes it really easy for you to trigger Lambdas from different places. Obviously developer friendly because you're just focusing on your code and you're not worrying about all the other stuff and managing infrastructure and of course managed runtimes, right? And that comes with sort of us taking on the undifferentiated lifting of doing all the stuff while you just focus on your code. And some of the common workload needs, Julian obviously spoke about burst concurrency and our 3000 burst concurrency limit. Now that is actually something we updated our documentation recently. Now that is something, the 3000 is our limit and you can do a lot with 3000. Now for certain workloads like the RennaisanceRe use case that fourTheorem is going to talk about, you may need more. And the Lambda team is always open to listen and understand and sort of say, okay, these are use cases that may need more. So okay, let's go ahead and figure out what we need to support you, right? So we're always open to have that conversation. And of course, a lot of times you may need to fork between Lambda and other compute sort of options based on constraint or cost. And I think that is a perfect fork over to the fourTheorem team to talk a little bit more about that. So with that being said, I'm going to leave it and go on to the interesting stuff. So over to you guys.
So yeah, Eoin or Gil, who's gonna start us off with a running chicken? I love it.
Yeah. Eoin can start. Yeah.
All right. Okay. We're gonna tic tac on this anyway. So yeah, we're gonna talk about the kind of situation where we addressed exactly what Aditya was just talking about, and I guess didn't start out thinking that Lambda would be the solution or even that much part of the solution, and it ended up being pretty pivotal to it. So Gil, do you want to just introduce yourself real quick?
Oh yeah. So yeah, hi, my name is Guilherme. I'm a software engineer for fourTheorem, like we said. If you want to get in touch, those are my socials. And yeah, I've been working especially with serverless over the past 4 years and helping migrating very different type of workloads to the cloud, especially in serverless.
Yeah, and I'm one of the co-founders and the CTO here at fourTheorem, and all my contact details are there. Julian was kind enough to mention our podcast as well, so the link to the podcast is on the bottom of the screen, and it's AWS Bytes. And if you'd like to give us a subscribe, hopefully you'll find something useful there. Okay, so we're talking about financial modeling, and in this case, we're talking about potentially using massive compute, right? So running millions of simulations is mentioned here. And ultimately what this means for a business like an insurance company, or it could be something in capital markets or any of the big financial players, we're talking about using historical data, inputs, contract data, lots of different market input sources to make informed decisions that are really critical to managing large volumes of cash. And the common characteristic for most of these applications is that they're incredibly compute intensive. And there have been lots of different traditional solutions to this in the HPC world. And a lot of people out there will know what they are, from MPI down to distributed computing. You've got parallel cluster in AWS. There's lots of different great solutions, a lot of them that are really specialist, built for the domain of high performance computing or scientific modeling. One of the customers we started working with a couple of years ago is RennaisanceRe, and this is a reinsurance company. So their job is to insure the insurance companies against risk. And they're looking at things like catastrophe events, hurricanes, earthquakes, as well as non-catastrophe risk as well. And they're, I suppose, expert at a number of things. So managing large risk portfolios, and figuring out, how they can best serve the market and pay people quickly when a catastrophe event occurs. And in order to be able to do all of that, they need really good technology that responds quickly and gives them good insight. They're also, apart from being experts at this risk modeling business, also very technical and very good technology decision makers in general. So when we started working with them, they had a challenge that they wanted us to look at. And there was two primary workloads here. And they're both in the same kind of algorithm space, which is risk modeling. And it's really just about understanding the portfolio of risk better and faster, right? So they've got a lot of quantitative engineers. They've got this real core intelligent piece of simulation modeling that their excellent engineering team has built up and is constantly optimizing and improving. So this is a HPC workload which they've been running. This is a couple of decades old, RennaisanceRe. They're well used to doing this. They know exactly what they're doing. It's a big workload though, right? It produces or processes around 45 terabytes a day, but it doesn't, at least traditionally, run more than once or a couple of times per day. Now, there's a couple of reasons for that. It's not necessarily because they don't need to, but because traditionally on premises, compute constraints don't really let you. The other workload is deal analytics, and this is the same algorithm, but it's a completely different shift in user expectations, because rather than being a batch process that runs once a night or a couple of times a day, it's where you've got an analyst and they're trying to tweak a deal, and they may have somebody on the phone and they need near real-time pricing using the same risk model. Now, luckily, the input data volumes aren't the same. It's just for a small slice of the same workload, but there is a much higher frequency of execution. So we're talking about thousands per day, and it's very seasonal as well. So you've got massive spikes and peaks. And we're talking about an on-premises system, which we started looking at initially. And this is, very much based around Python ecosystem. You've got a SAN for file storage, RabbitMQ for messaging, kind of a service-oriented architecture, and using Celery for orchestration and scheduling. The primary challenges you could probably anticipate if you've looked at systems like this: long execution time. So we're talking about nightly batch jobs that are starting to take the whole night and risk bleeding into the start of the day, especially when you've got a global company. Competing workloads is another big one. So we're not just talking about being able to scale horizontally in order to do the same workload faster, but also being able to scale horizontally so you can do more workloads concurrently. For RennaisanceRe, that meant, there was really a cap on their business growth coming down the line if they didn't address this. And as well as that, all of the maintenance of this system, the orchestration, the hardware, the data center, ended up being quite a large cost of ownership for the engineers, and it was kind of really constraining that growth, right? So, they're good engineering minds at RennaisanceRe. They kind of knew what was on the cards here. So they came to us and said, okay, what we want to do is we want to look at a system that's going to give us a massive increase in performance. We want predictable runtimes. We want more executions more often with more users running parallel workloads, and we also expect that our portfolio is going to grow. It's going to grow in business, but it's also the data volume is going to grow. So the initial goal they set up was take this workload that's running overnight in, sometimes 10, 12 hours. Can you do a POC on AWS where you can run that roll up in an hour? And that's where we started. And we ended up evaluating very quickly a lot of different services, approaches. In collaboration, we kind of worked as a collaborative team with them and did lots of interesting POCs with lots of serverless goodies and other things as well, like EC2 and batch. And we learned a huge amount together with them.
Oh, and how do you actually even approach that kind of analysis? Because, you, as you said, fourTheorem does a lot of migrations. There's a lot of different things to use. I know you do a lot of serverless things, so you are looking, possibly at a serverless first approach to do that. But with all the different solutions, how do you even have the conversation with your customers as to, because they may not even know what the various services are and they've all got different use cases?
Yeah, well, I guess the approach we try to start out with is that the approach you try first isn't necessarily the one you're going to end up with. Yeah. So we sit in a room and we look at what might be the closest, I suppose the quickest win in terms of learning. Try that first and then quickly iterate on it over time. And at that period, you end up swapping out services on a daily, weekly basis and trying different things. And you're measuring all the time. Like at the start, we spent more time putting in measurement capability than we did implementing the system so that we got the metrics to actually evaluate things. Gil, I'll leave it over to you.
Yes. So we're gonna start talking about what we chose for technology. So of course we wanted to focus on a serverless approach. So I started evaluating, okay, so what are the components that we're going to be using? So For a storage, we're going for S3. Yeah. So that is where we store our inputs, outputs, and the aggregation files for each of the execution. And those files we're talking about CSV files, JSON, or Parquet. Yeah. And we need to read and write like thousands of objects per second into S3. So we need a high throughput on that. Like Eoin mentioned, on every execution, so we process 45 terabytes of data. But on the other side, we produce 600 gigabytes of data on each run. That's the scale of this nightly rollup that we have. And for the compute, so we have a mix of Fargate and Lambda. Yeah. So what we use each for. So Fargate is we run the tasks that we can wait for the cluster to warm up and scale up. So we don't need immediate results out of that. So we can cope with that. And also to support bigger and longer jobs that we know that they would go over the 15 minutes timeout limit of a Lambda. Yeah. And that gives us like a little management overhead there. And on the other side, we have Lambda for the kind of runs that we need to scale up as fast as possible. Yeah. And we can execute their smaller and quicker jobs. And that all of that with like very little management overhead. And another distinction between the two is like, okay, what are we optimizing for? Are we optimizing for cost or for performance? Yeah, so the nightly runs that they usually run during the night or sometimes a few times during the day, we can reduce a bit of the cost because we can wait a bit longer for those results to come out. So this is like a high-level view of our architecture. So we have three main components there. The first one is the planner, right? So the planner is just a step function where we have like a bunch of lambdas and steps there that they build an execution plan that will describe how these jobs will be executed, yeah, and what the order of their jobs, the order they need to respect. The second component there on the center is the scheduler. Okay, so the scheduler they control the order of these jobs. They ensure that they'll be executed in on the order that these execution plans is driving. Respecting their dependencies, and also it keeps tracks of the state of each job. Am I still running? Have it failed? Do I need to retry it? I'm done, so now I can schedule all the next batch of jobs. And this is all event driven, so using lambdas with Kinesis, and all the job states we keep in Elastic Cache on a Redis server. And on the compute side, so we have the two that we said. So we have a Fargate or Lambda, yeah. So they're both, those two, they kind of workers. They pretty much have the same code. They execute the same code, but they just have a different wrapper. Am I running this on a Fargate wrapper or on a Lambda wrapper? On the Fargate, the only difference there is that we have an SQLS queue in front of it. So we send those jobs, and then the containers they keep pulling messages out of that. And they both, what they do, they read their inputs from S3 and they write their outputs back to S3. Yeah, and how the compute is decided is on, you can see there on the left, like the type of execution. We have a roll-up or we have a geoanalytics. That's what is going to decide the type of compute of them. Yeah. So if
the sorry, I just had a question. The execution planner itself, was that something? So to me, that seems like the place, like to your point, where it says, okay, like it's a analyst dashboard thing. So now we need to use Lambda versus it's a roll-up thing that needs to run longer. So it's going to use batch. Was that something you folks wrote yourselves and built yourselves, or did you use other AWS services to build the execution planner itself?
Yes. So in order to build, actually, we have here a bit of explanation on this slide.
Okay.
Yeah.
I jumped ahead.
In order to build this execution plan, we need to know the relationship between the deals. Okay. So we get the whole portfolio, and we know, okay, how it's as a graph representation of all these deals. Yeah, and the aim, the goal of this step function is to compile it, and create this execution plan, describing how the dependency chain is. Yeah. So when we start executing these jobs, we need to start executing the ones without any dependency, and then drive through the tree. So always like in a tree, always from the leaves to the roots. So this is the main thing about the planning phase. Yeah, and how we create it.
So that's fascinating.
Yeah.
So do you have then an input which goes into the step functions, and then that's sort of some decision tree? Because yeah, step functions is really helpful with that. Instead of having to write your own Lambda function to take an input and then do X or Y, just get step functions to, so you don't have to, you're not having to write your own code to do all that, or retry and error handling and all that.
Yeah, and especially for this type of workflow, that we need steps to be executed in sequences. Yeah, so first I need to fetch my data. Maybe I need to fetch some more data related to the first batch. Yeah, so it would be way more difficult to approach this on an event-driven. So we can just orchestrate that with a step function. It really helps a lot. And not only with Lambda, because we also can use the direct integrations. Yeah, so this would save us like having to write a Lambda just to transfer some data. Yeah, and so here is a better view of the execution plan, how it is. Yeah, so at the end of the day, it's just a graph, right? So on the first line highlighted there in green, we can see that those are the jobs without any dependency. So the scheduler can start executing them all in parallel. Yeah, and then as we go to the next line, so all those jobs, they depend on the jobs from the first line. So this scheduler, it needs to keep track and monitoring the status of those previous jobs. Once they are done, then it can schedule the next batch and also execute them in parallel. And as we go deeper on this tree, we can see that those relationships, they start getting more complex. Yeah, so we have a job start having lots of dependencies, sometimes cross dependencies. So how can we make this efficient, right? The goal of this is make it efficient, so we can have better cluster utilization, yeah, and therefore we have faster execution times. But that was just a simplification. This is, in reality, not all the jobs are the same. Yeah, so we have smaller jobs that they take like seconds to run, or we have bigger jobs where they have multiple dependencies and they take, let's say, half an hour, 45 minutes to finish. Yeah, so we end up with all these jobs, and these end up like reducing the parallelism in a significant way. So how can we fix this? What was the approach we took to fix this? Horizontal scaling, as we got the comments before from the stream. So how we did that? So our execution, we start with like 1,000 of these jobs, that they're just the tree of all the deals we got from the portfolio. And a good way to describe these jobs is like, think of them like a CSV file, yeah, where each of the line of the CSV file represents a cash flow information. These lines, they are not dependent on each other. So we could split those lines, chunk them, and execute them in parallel as chunks. Yeah, and splitting these jobs, and every sub job would be responsible for one portion of this original input. That's a good representation to create a mental model there. And the same goes for like subsequent nodes. We apply chunking as well, but then we have a relationship between each of the sub jobs. So they depend also on a specific chunk from the parent. So we don't have like a cross dependencies there. And that's great because now we can scale horizontally and have much smaller jobs. But this, of course, ends up increasing the order of magnitude of the problem. We have way more overhead. Yeah? But this ends up making much easier to parallelize. Over back to Eoin. You'll be talking a bit more of compute then.
Yeah, I guess. So I mentioned that at the start, we'd looked at AWS Batch, right? Because Batch is essentially a job orchestration system for HPC workloads. And it has things like dependency management, etc. I guess in general, at least at that time, it was more optimized for jobs that take a little bit longer to run. So you're really quite happy to wait. You don't have to worry too much about looking for a 100% cluster utilization. We were looking for a little bit more of efficiency here. So we moved to Fargate and tried out this kind of scheduling algorithm that Gil just described. And with Fargate, we discovered that we were able to, I guess, get a little bit more control over the orchestration and scheduling, and then leverage things like step functions, Lambda in places to really get that tight control over it that we wanted to. So essentially what this means is that we've got a couple of key systems. I mean, S3 is really the core of the system in a lot of ways, right? And it means you don't have a lot of database complexity in terms of your data in and data out. S3 is really taking care of everything, scaling incredibly well. Fargate is able to scale up to thousands of containers for us pretty easily. We're able to take advantage of Spot as well when we need to. We've got SQS feeding the jobs in, and then each container, we try to simplify it as much as possible. So each container is essentially pulling one job off at a time, processing it, acknowledging the message, and moving on. And then we use Redis as actually the throughput mechanism to get the state change information out of that system so that it can be processed separately. Lambda, on the other hand, is using Lambda's own internal queue, so we don't add another queue to it. We just invoke Lambda and let it, with an asynchronous invocation, let it scale up, and it scales up incredibly well. So for that deal analytics workload, we're able to get thousands of Lambdas spinning up concurrently and spinning down right away. And it's interesting. There was a concern, I guess, that the cost difference between Fargate and Lambda would mean that Lambda was going to be a little bit too onerous in this case. But in fact, it's deceptive really, because you end up getting so much efficiency out of the fact that Lambda's down to 1 millisecond billing, and you never have any waste with it. Every time it's running, it's doing something. So when you look actually and compare the costs, you have a lot of efficiency out of Lambda, and everybody was kind of surprised at how efficient it was in the end. So I guess just on fault tolerance then. So one of the things we're constantly looking at is how we can kind of improve this and see if there's AWS services that are adding features that mean we don't have to have this, as beautiful as we think it is, this custom scheduling algorithm that we put together with step functions and Lambda. We're always looking to kind of delete code. So we're kind of keenly looking at step functions, distributed map, and seeing how we can apply things like that to this workload. Because if you look at this, we end up building this neat bit of architecture, which is using Kinesis and Lambda, and then Elasticache Redis for the state of all these millions of jobs in any given workload. And it's constantly churning through every event that comes in, looking it up in Redis, updating the state, and also managing errors and recovery, right? And as you pointed out, Julian, like step function is able to do that for, I suppose, more predictable orchestrations, right? Where you've got a declarative graph. I think distributed map is an interesting one to watch, because if that ends up being capable of handling workloads like that, we'd certainly kind of jump at it in order to be able to delete a whole bunch of code that we don't have to worry about anymore.
Yeah, and I mean, I suppose ultimately with distributed map, your Lambda functions that are doing the actual crunching are just going to stay the same. It's just the orchestration piece around that and the pulling things off S3. And for people who don't know, distributed map for step functions is, in a way, serverless map produce for the cloud. I'm sure I'm going to get haters who are going to say that that's not entirely correct, which it isn't. But if you can think of it in terms of that kind of process, you can put JSON data, CSV data, a whole bunch of data in S3. Step functions will pick that up automatically and then fan that out to thousands and thousands of Lambda functions, and then step functions can handle the reduced step at the end.
Yeah. I think that ability you mentioned, like keeping the compute workload the same, and you swap out the orchestration. Decoupled is the real important feature of this architecture, I think. So you got Gil mentioned the planner. Like the planner is completely separate to the execution and the scheduler. Those are three kind of completely distinct areas. One of them can be swapped out, right? And that makes it kind of amenable. One of the principles we try to follow is to try and make your architecture decisions like two-way doors and your code deletable, so that you can quickly adapt as you suddenly get these opportunities to really just take away a whole bunch of code you don't have to maintain anymore. So to cut a long story short, I suppose, in terms of business outcomes, we got that roll up in an hour, and actually is because of the horizontal scale, you can actually do it in faster than an hour now. It's just a question of changing your numbers. The limits of the number of runs is gone, so now they can do parallel runs. They can do they can have analysts concurrently. They don't have to wait for the weekend for the cluster to be available to run special workloads like they used to, and they're now engaged in a whole set of other AWS related projects because of the benefits this brought. A couple of benefits that are, I suppose, worth pointing out are the reduction in code base by about 70%. I suppose the ability to just focus on, building new things and not worrying about all that infrastructure they have to worry about, and just in general, team agility. And RennaisanceRe are, I suppose, a socially and environmentally responsible company as well. So the fact that this workload is efficient from a carbon footprint and a sustainability point of view is very important to them. And it's something they're measuring and constantly trying to improve as well. Now, one of the things about this is...
Yeah, Vinicius literally put that question in the comments immediately, and I was thinking in the back of my mind, yes, quotas, limits, accounts, all of that kind of thing. Interesting to hear, yes.
Yeah, I mean, this is one of the things when you're pushing the boundaries of using this. I mean, ultimately, the principle behind this architecture is that rather than using bespoke HPC systems that you're kind of stuck with and may have constraints, you're using commodities, components that you can kind of replace over time, right? And you can hire skills from people who've got them available in the market because you're using commodity compute like Lambda and containers. The trade-off there is that sometimes when you're horizontally scaling to this degree, your compute can scale, right, to tens of thousands of nodes, but you have to think about, okay, what is that compute doing? Is it communicating with other systems like on-premises systems or other AWS services? And what are the limits of those things, right? So this is a really important thing to think about. And Gil mentioned that we've got tens of thousands of reads and writes from S3 per second. For people who've worked with S3, you're probably aware of the throughput limits. You get 5,500 reads and 3,500 writes per second by default with a bucket. And it has this amazing algorithm that scales for you so that if you start writing faster, it will automatically try and figure out which partitions are hot and then allocate more partitions with their own throughput allocation. In rare cases, and we were lucky or unlucky enough to be one of those rare cases in this particular workload, you can end up with a certain write pattern that doesn't automatically trigger the partitioning for you quickly enough. And then you end up getting throttling from S3. And this is obviously something we discovered in development, not in production, because we're running at the workload we expect to run when we're testing. So what we were able to do in that case was talk to the S3 team, talk to our solutions architect, and figure out a solution. And by talking directly to the team, they said, okay, we can figure out a solution for you. Tell us how many partitions you need in advance, and we'll fix that for you, and we'll guarantee you that throughput. So this is one of the examples of, I suppose, being in the rare kind of less than 1% of AWS users where you hit a slight edge case, but we were able to resolve it just by talking to the right people and leveraging the support that's available. So yeah, and this is something you just have to plan for then, right? Because if you need something special like explicit partitioning, you have to think about that when you're creating multiple accounts with different environments. Another one to answer that question is around Fargate scaling. Gil, would you like to talk through this? Because you're
yeah, that was a very interesting one. So we wanted to run 3,000 containers. That was the limit, the soft limit we had at the moment, as soon as possible, right? So how can we do that? Yeah, so we were just using the normal setup, let's call it like that, and that was taking like over an hour to us, and that was not really acceptable for that use case. So we had to find a good way to improve that. And again, so we talked to the AWS team. Let's find out what can be done there. So there are two ways to scale up a cluster, a Fargate cluster. So the first one is the normal approach. You define a service with a specification. You say, okay, so I need to run a certain number of containers or tasks for this service, and then you can define your outscaling groups based on specific rules. Yeah, and what we found out back then, it was like this was designed to be work better like on a web scaling. Like I have a website and I need to scale on that proportion for that kind of traffic. But for us, we need it much faster than that, slightly different way. The second way we found out is like you can actually just use the run task API and manually invoke and request new tasks to be created. And then we did some tests. We did a POC on that. And then we realized that we were able to scale to 3,000 containers in only 20 minutes. We didn't have to wait for 1 hour anymore. But that required us to create a custom scaler, of course. So we use the step functions. And this step function is pretty fun because it just keeps working a loop. And on every iteration of this loop, we monitor, okay, do I have any incoming executions on the way? And how big are they? What is the amount of jobs I have for it? So I can start pre-warming the cluster meanwhile. Because in between the moment we know how many jobs we have and actually we start executing those jobs, we have a gap there. So we can prepare warming up the cluster in advance. So that's one thing. And then we just use this run task API to request until we reach what our target concurrency is. But of course, even with that API, we have limits on that. We cannot just abuse the API because otherwise we start getting throttled like we got with S3 back then. So what we found out that on every execution of this run task API, we can request a maximum of 10 tasks to be created. And in between each of those requests, we had to wait 3 seconds. We have to have a 3 seconds interval there. Otherwise, we get throttled. So we designed this. This is why this step function was designed on a loop way. So we can keep monitoring that flow and scaling as we need. And also, why this is on a loop? Because containers and lambdas, they can die for not only for code-related issues, but like you can run out of memory. You can have a network issue. So suddenly your cluster is losing capacity. So this scaler is also able to pick that up and request more for you. And yeah, and something good to mention is that since then, the ECS team have made like lots of improvements. And now we can scale up to 3,000 containers in under 5 minutes. Yeah. this is important to highlight. So we built this pretty much like 3 years ago. And since then, the scenario has changed relatively. So now we can scale up to like 10,000 concurrent Lambdas in a fraction of, in a few seconds, or even 10,000 containers in under 2 minutes. If you want to find out like what kind of performance you can have, like on this link on the slide, there's a very good case study made in 2022 by a guy called Vlad Ionescu. I hope I'm pronouncing that right. So he benchmarks like how Fargate can scale to like the maximum capacity in many different scenarios, different kinds of configurations. So this is a very good resource to have a look. But this was done in 2022. So probably it has improved even more by now from that state. And yeah, just to wrap up. So we managed to get like all this supercomputing with serverless, in HPC, just using AWS commodity compute. We had lots of challenges, of course, but we learned a lot from those challenges, and it's doable, and we get very great results at the end. We get the benefits of innovation. Now, if you look at RennaisanceRe, they have like a serverless-first approach, and this is amazing to see, like a company adopting that, and the agility that serverless gives you. You don't need to think about maintaining servers anymore, patching updates, and other things related to that.
So, Gil, I mean, were RennaisanceRe doing some serverless things beforehand, or was this sort of the intro to serverless? Because this seems like a pretty big workload to start with that. So yeah, which way around was it? Were they becoming more comfortable serverless after doing this whole project, or were they comfortable serverless beforehand, and so they were comfortable doing this project? Or you were there obviously as fourTheorem to hold their hands, so you could advise them.
Yeah, I'll just let Eoin answer that, because I joined when this project had already started. Yeah.
Yeah, I mean, I wouldn't say it was there on the table when we first went in the door, Julian, but they were already using some AWS services like Redshift Data Warehouse, for example. Yeah. When we started looking at different ways to experiment with the POC and figure out how we could get that to that magic 1 hour number, we tried a few different things, but we were always, because we were trying to iterate quickly, we were saying, well, look, what we can do in order to create a plan, in order to run it on batch or EC2, we'll just use a step function and some Lambda functions. And by working together with them and showing them, there was kind of a light bulb moment where they could see that it was so quick, so fast to innovate and alter that quickly, that it suddenly light bulbs started going off and people started getting very enthusiastic about it. Now, it still took, I guess, time to really say, okay, well, let's run our financial modeling workload on Lambda. But they were very comfortable. I mean, like I say, they're kind of known in the industry even for being kind of technology leaders. So they're always kind of a bit ahead of the game. So they're, I suppose, early adopters in that sense. But they ultimately they don't want to be engineering on something that isn't core to their business. So if they see an opportunity like that saves money, they understand risk analytics, right, as part of their business. They understand how to optimize things. So when they see the benefits, they say, okay, this is clearly the way to go.
Yeah, and it's interesting because you mentioned this was done a few years ago. So it's not as though, all Lambda features, this is, bleeding edge, just to say, Lambda's come out with something in the past month or two that enabled this. This has been a long approach over many years. What I've liked is that you've even sort of seen, well, there are advances since then. And, I suppose that's part of the journey and part of the evolution of these kind of architectures is looking at what's possible as things evolve.
And it is, and a very good comment on that is that when we started this project, so we realized that we couldn't run any of the modeling jobs on Lambdas because a Lambda didn't have enough memory for us. And then Lambda increased to 10 gigs of memory. And then we managed to create this, have this shift, and now we have the 2 compute options there.
Excellent. Yeah, things are continually evolving. So
I did notice one question in the chat, which is around using multiple accounts to try and achieve parallelism, and that's always a temptation. And every time we run into a limit or some sort of constraint, one of the first things that somebody suggests is, well, if you use multiple accounts, then you can just, stripe your workload across all these different accounts and scale that way. And it's certainly tempting, and I wouldn't rule it out, but I think you just have to think about the complexity you add then in terms of deployment pipelines, keeping those environments in sync, monitoring multiple accounts just for one workload, right? It's okay if you've got different services or domains or teams, but if you've got one team and they're trying to monitor a fleet of production accounts for one workload, I think that's something you kind of have to go into with really a bit of foresight.
Yeah, I mean, Aditya can jump in here as well if you have anything extra, but I think, the recommendation, as with all AWS things, is the account limits are there for good reason, to, for blast radius, for security controls and all those kind of things. But in this use case, it is a single application. In fact, the blast radius is the opposite. You want an inverse blast radius because you want this to be able to blast and get as high as big as possible. There's lots of great advice on doing multi-account strategies, but that I think is super useful for different users or different parts of an application. Specifically, if you're building event-driven applications that are decoupled, that can be useful. I think in this use case, as Aditya said in the beginning, the Lambda team is super keen to hear your use cases. There are a number of limits that can be tweaked and can be manipulated, and we can give you advice as well on how to run them for your workloads. But a big account with limit increases for a lot of services for a single workload in this use case seems as though that was a good choice. Well, I think this has been absolutely fascinating. I think it's really showing how the sort of scale out computing with people who have been thinking about HPC in the back of their minds. And this is a financial risk modeling, but, even looking at the, COVID genome research, I know there are case studies on the AWS blog about that, but it wasn't just financial use cases. There's a lot of number crunching that needs to happen. And I think that, abstracting all this infrastructure and the simplicity of Lambda or a Fargate with a container solution, where basically the scaling challenges, the networking challenges, and the throughput challenges are just become AWS's problem. And our clever engineers can sort that out is attractive. So I just want to say thank you, Eoin, Gil, and Aditya. Sorry, Aditya, carry on. You were saying something.
I was just going to say, from the Lambda side, we would love to see more people pushing the boundaries of what Lambda can do and coming and challenging us to say, hey, this is a problem for us. Can you solve it? So like I think there was a bit of advice from Eoin, reach out to your account teams, reach out to us. We're happy to have a chat. We're always interested to see what people are building on us. So I hope this was an amazing example to me. So I hope to see more of these.
Excellent. Well, also, there is actually a blog post about all of this, which I have put in the stream notes as well, and it is popping up on your screen. That's a lot to type, so maybe just go to the stream notes and you're going to be able to get it for you. But thank you very much for joining us. Just to quickly, before we wrap up and say goodbye, actually, next week, we're going to be talking about benchmarking Lambda cold starts. So Maxime David, who actually works for Datadog, has built a tool that I think daily goes through every Lambda runtime in every region and benchmarks cold starts to see how they are going and how they're improving. And I hate to say, sometimes do get slightly worse, but they get improved over time. And so, this is really peeling back on the onion how he managed to handle all of that. So, super useful to get deep and nerdy into Lambda cold starts, which we'll be talking about Maxime. It's not Mazim, it's Maxime David, my typo over there. And also, serverlessland.com is for all things related to serverless. We've got plenty of learning paths which are popping up on the site as well. In fact, under the learning page, if you go to serverlessland.com/learn, huge amount of content has been really added, and my colleague Dave Boyne has done a super good categorization thing. If you're looking for workshops and guides from Java replatforming to cost optimization to testing strategies to one that I've done is Lambda fundamentals. So if you're even scratching your head and going, what is the serverless? What is Lambda? That's a really beginner's guide to help you take through that journey. So thank you very much. Don't forget EDA Day Nashville. Sign up for that. We'd love to see you there, and lots of other things on serverless land as well. So thank you very much for joining us. It's been super useful. We are actually going to have some fourTheorem folks back on in a few weeks to talk about some observability with one of their tools. But until then, thank you for your time today. We really appreciate you being on Serverless Office Hours.
Thank you very much. Bye-bye.